Welcome back to Harbour Unboxed. For today's video, we're exploring part 3 of why it's a bad time to build a PC. I'm filming at the moment. Oh, Matt.
Hey, how you going?
Not bad. What's going on?
Well, my computer's died and I need help.
Alright, give me a moment, guys. Alright, we're back. I've looked at Matt's computer and tried to work out what's going on with it. Unfortunately, it looks like his motherboard has died. So, reasonably easy component to replace there, but we've decided to build a new computer anyway, because you're doing some more work now on your computer.
Yeah, I do lots of video editing, so a bit more grunt would be nice.
Yeah,
for sure.
What have you got at the moment? It's a
4670K, yeah. So
So 4th gen Haswell Core i5, so only 4 cores, 4 threads. So we thought, you know, more grunt is definitely needed there for encoding and work and all that sort of stuff. So, as you guys know, it's a pretty bad time to be building a new computer and all that.
Yeah, very expensive time to be
Matt's
building a new
noticed.
computer.
We could pick up a Z97 motherboard or something like that for not too much, though they are quite expensive for what they are. It kind of almost makes sense. You can get B350 motherboards cheaper. And with the Ryzen 7 1700 being recently discounted, it's probably a good time to pick up.
Seems like a good excuse.
Yeah, good excuse anyway. Maybe not a good time. That's probably not a good
time, but a good excuse.
Yeah, so that's what we're going to do. We're going to build Matt a new computer today. We're going to ditch the old one. We'll bring over most of his storage and all that sort of stuff and things that we can. Possibly the graphics card. You play a few games, don't you?
Yeah, now and then.
A casual gamer.
Casual gamer.
So we've got to work out what we're going to do about the graphics card. Whether we stick with the one you've got, which may be a way to go, or if there's... We might do some benchmarks with a few different options and see what you could do. So we're going to go over all the parts that I've worked out that Matt can have for his new build.
Looks like he had some spares.
Yeah, there's a couple of spare parts. So we'll work out that, and we're going to probably do this in 2 parts. So the first part, we're going to work out the parts. We'll actually test them outside of the computer case to get like a best case scenario, if you will, for temperatures. And then I have an interesting case that you'll see in a moment that we're going to be putting all the parts into. So let's get to that. All right, so I've got the case. Here you go.
Ooh.
You can tell it's quite pretty.
Nice one.
So, sure some of you guys are familiar with this case. We'll talk about why we've picked it in a moment and what we want to test and work out. But anyway, we'll get to that in a second. All right, we've got the motherboard. Power supply, you'll need that. The Naya.
No. So many fans. And RGBs, of course.
Okay, and we've also got the new Crucial MX 501TB SSD, so we're going to give that a whirl in the build. We're going to go with the Ryzen 7 1700, and we'll definitely be overclocking that. It'll be interesting to see what temperatures and things are like. And as you said, we've got some RGB lights, of course. We've got the Naya 240mm all-in-one liquid cooler. We have the BitFenix Formula gold-rated 750-watt power supply, so that'll power everything nicely. Then with the motherboard, a little bit overkill here with the Gaming 7, and that's an X370 motherboard, so not necessary, and it's probably not even a wise investment because we know we've got the X470 boards coming out in a few months' time with the 2nd generation Ryzen CPUs. So if you were building right now and you couldn't wait, you had to build, kind of like the situation Matt finds himself in because he's got to get work done, he needs to get it done quickly, hence the upgrade. So a B350 motherboard would be the way to go there. But anyway, this is all I have spare, so Matt's getting a nice upgrade there. You haven't lost your edge.
Still got it.
Still got it, mate. Okay, so we've got the core components ready. We've got our Ryzen 7 1700. We're about to install that in a moment. I'll probably make Matt do all that. Do you remember how to build a computer?
We'll find out.
We'll find out. So that's going to happen. We've got the memory, the power supply, all that stuff. We're going to grab a monitor. We'll grab a test system, SSD. Get it all installed, do about an hour's worth of stress testing and record the temperatures. We've got an ambient room temperature of 21 degrees. So we'll compare that to the final temperatures in the case once built in the BitFenix Enso case. So that should be interesting. All right, let's get building, or at least roughly setting up. I'll let you You can slot the CPU in. I'll get some thermal paste. Come on, you can do it. Actually, I might not even have the monitor set to the right input. I might not even have the monitor turned on. Pro tip, guys, turn the monitor on. Oh,
We did it.
we did it. I had my doubts, but we did it.
Take this.
So if you want to take that home, we're done now. Alright, so we've put together our test bed. We've got it all set up. It is actually working. Oh, there you go. Look at that. Working. So
We did it.
we did it. Yay for us. So we're all set up. We're about to run some stress tests. At the moment, there's been no overclocking done. We've just loaded the optimized BIOS, or BIOS defaults basically. So we're going to run some temperature tests there, and we'll be able to compare the results we get on the test bed here to when it's in the case. So that's the most important thing, so we can measure the difference the case makes there. And yeah, so we're going to do that first with the default settings, then we'll overclock it, and we'll come back and let you guys know what temperatures we found. Let's talk about the stock results for the Ryzen 7 1700 or the Gigabyte AX370 Gaming K7 motherboard. Again, the ambient air temperature was 21 degrees, and AIDA64's CPU and FPU stress test was used for all the load testing. Under full load for an hour, the CPU temperature peaked at just 44 degrees, which is really a great result for an 8-core CPU. Perhaps more impressive though was the fact that the pump in the all-in-one liquid cooler operated at just 1700 RPM and was virtually silent, while the two 120mm fans were basically silent, spinning at just 800 RPM. The VRM temp, that was reasonably good as well, reaching just 60 degrees after the hour-long stress test, so that all looks really good. Time to overclock. The Ryzen 7 1700 has now been overclocked to 4 GHz using 1.375 volts. As soon as the overclock configuration was placed under load, we exceeded the previous maximum temperature of 44 degrees and quickly climbed above 60 degrees. Before long, the system maxed out at 76 degrees, though Hardware Info did report a spike to 85 degrees. Matt and I monitored the last 20 minutes of stress testing, and it held at 76 degrees for the entire time. So looking back at the log file, we see that the spike to 85 degrees only happened for like a second, so perhaps that was just a glitch. The real concern here for Matt, though, are those VRM temperatures. Shockingly, the Gigabyte AX370 Gaming K7 hit 112 degrees. Unfortunately, I decided to touch the VRM heatsink before just looking at the monitor and checking what Hardware Info was reporting. It was a pretty clever choice, that. As a result, I actually burnt my finger slightly, and while I was jumping around complaining, Matt just laughed at me. So we got out the IR gun and we aimed that at the VRM heatsink, and that reported a temperature of 98 degrees for the aluminium heatsink. So it's fair to say the 112 degrees reported by Hardware Info is accurate. Although we are using an all-in-one liquid cooler, the 120mm fans were actually directing quite a bit of airflow over the VRM heatsinks, given how we'd had situated on the desk, and it wasn't really hot air either. It was certainly warm air, but not hot, so this is going to be something we'll need to try and address when putting the motherboard in the BitFenix case. Anyway, that's going to do it for part 1 of building, fixing, upgrading Matt's computer. Part 2, we'll of course put it in the case, do all the temperature tests, and show you guys the build process, and that should be pretty cool. Keen to be getting your new computer?
Yeah, let's do part 2.
Alright, Matt's ready to go. I'm your host, Steve.
And I'm your host, Matt, as always.
No! I was trying to work out this right button. Alright, hang on. I'm gonna like genuinely act very upset with you for your thermal based application. Alright.